Good morning, everyone. Good afternoon. Good evening. Who knows where you are? You know where you are, hopefully. So we are back. We are live. We've got Steve Walker on the line. We're going to be talking about the Stellar Turrets Turing signing server, however you choose to call it, protocol. This layer 2 solution for composing and signing Stellar transactions such that you can build some interesting DeFi protocols on top of Stellar. This is going to be a technical workshop. We're going to be actually getting into the code. We've got about a 2-hour slot, so feel free to jump in and out as needed. We'll try and get through questions, so as you have them, feel free to put them in the chat. I'll do my best to monitor some of that, though I will be coding. Otherwise, we're just going to have a nice conversation with Steve. He is working at Task.io. If you've been keeping track of the Stellar Community Fund at all, you'll know that his company Task.io recently got some funding from the Community Fund, and he is now pursuing some different protocols and products and services on his end, and looking to learn a little bit more about the Stellar Turing signing server protocol that I've been working on to see if it might work for some of the stuff that he's building. So just kind of a general education workshop. Thought it might be beneficial to the Stellar Quest group, as well as anyone else who's listening. Welcome. Steve, if you want to go ahead and intro yourself a little bit, and we'll just dive right in.
Yeah, thanks, Tyler, and thanks for setting up this session. This is a great opportunity for me because I'm going to ask lots and lots of very, very dumb questions. From my kind of situation as a CEO who's techie and plans product, I just want to get fast insight into everything that's going on around turrets. I started setting up the servers. I've set up the task turret server, and then I'm going, right, what do we do next? And while I could be diving into docs, as I'm not a proper coder, and there are much better coders out there than me, or there are actually real coders out there, as I'm not. But that doesn't matter, because what I'm hoping we get out from today is a easy to understand overall structure with turrets that will inspire and get other people to get smart contracts running across Stellar. I mean, I think from a business opportunity point of view, I won't go through the list now, and I know I'd explode your head if I gave you every request, Tyler, but the smart contract opportunity that I see that we can be utilizing in Task is absolutely vast, and it's from just small fixes to really interesting complete contracts. So yeah, I mean, let's dig in. I'm really excited, and this will be a fun session.
Super. So I'm gonna go ahead and jump over to the screen here. I'm on tss.stellar.org. This is kind of our landing page for all things turrets. The main repo that we'll be working in is our reference implementation, where all of the protocol is kind of being designed and growing up right now. So I'm going to go ahead and swing over to that. So there are lots of interesting things going on, particularly around the sponsorship of Turing signing servers, or when contracts are actually getting signed. And I actually try not to use the word contract too much within the protocol, because that term just carries so much baggage. I'm using a TX function as kind of synonymous with a smart contract. It's essentially a very small digestible, relatively small digestible function that produces a transaction, that produces an XDR. I'm going to give a real brief overview of what's happening behind the scenes in a Stellar turret. So the whole point of the Turing signing server network is to solve a problem around getting transactions signed. You can do smart contracts on Stellar without any problem. They're just not decentralized, because stellar transactions need to actually be created. At some point, you need to get a transaction built before it can be submitted. But you can build any transaction at all that you need, and the terms under which that transaction gets created are completely up to you, the service provider. So you can very easily, in your application logic, pull in a weather API and say, if it's raining on a Thursday at this location, create a payment. Like, you can create Turing-complete arbitrary programming logic from which a transaction gets generated. The issue is, right now, that's centralized. It always happens at the mercy of some centralized third party that creates this transaction underneath some conditions. That's not DeFi, that's traditional finance. And usually, like, that's not always a bad thing, but there still needs to be this option of, what if I didn't want a centralized third party answering the question, is it raining on a Thursday at this location? What if I wanted to put that logic across multiple parties? Decentralized finance, there's nothing really unique about that, other than you're taking computational logic or functional logic and running that same function across multiple parties, multiple disinterested. There's no reason, no incentive for them to collude, no ability for them to collude, to then like change the answer and produce a result that would be unacceptable. And so what happens in the Stellar, that what I'm trying to accomplish in the Turing signing server protocol, is essentially finding a programmatic, sort of everyone agrees on how this is done, way of creating a transaction underneath specific conditions, and then also getting that transaction signed. Because anybody in the world can sort of say, well, I want this transaction to go get signed, right? If you give me your public key, I can create a transaction that drains your account and pays me all that money. But unless you actually sign it, who cares what you wrote in your transaction? If it never gets signed, it never gets submitted. And so with Turing signing service, you need both of those things kind of put together, where if all you had was composition, the function could create any transaction, but if there's no ability to get it signed in a decentralized way as well, who cares? If all you do, though, is get something signed, you still need it composed. So you need both of those things put together, the composition and the signing of a transaction, for it to actually be valuable. And so that's what we're trying to accomplish here, is these very succinct functions that create a transaction, and then the signing network actually gets those transactions signed. They have a signing key associated with them, which is still useless until that signature is added via the multi-sig scenario. So in the case of making a payment, if you've got an account in question, if you want to sort of pass control of that account over to the Turing signing network, you need to add the signers of the turrets where the contracts are stored, add those signers to the account in question, the account that's about to make the payment, add the signer, and then whenever you run the contracts and it produces an XDR that's signed, you can actually get that submitted, either by combining signatures together for however many turrets you have, either 1 to however many, 20 I guess right now. You combine those together to actually get the transaction signed so that it's submittable. So it's a very useful thing to do. And then from there, you can kind of begin to build your arbitrary contract logic.
So just digging into that, so you're talking about I've got a transaction. I want it to execute automatically in my absence, and you hand that power over to the turrets, and you're gonna give permission for the turrets to sign on your behalf.
In a sense, yeah. So there isn't a concept of these things don't run automatically. There's a function that will run when it's triggered. So anyone in the world can trigger it, can run it, but they're not like run off of cron jobs. Or something like that. It is really important that right now the protocol is stateless, which will mean that certain DeFi solutions are not going to work well. You'll have to explore where some of those limitations are, because there isn't like this saved state between turrets. It's actually really hard to do coordinated state. That's the whole reason blockchains are interesting, is guaranteed state across multiple databases. So right now turrets are actually stateless. That doesn't mean they're not incredibly powerful and useful, and a lot of the statefulness that you might need to add can actually be included through memos or managed data attributes inside of the Stellar blockchain. But there are some limitations, and I know as we have talked before, around managing state, sort of arbitrary counting votes or likes or something on a post and keeping track of that. That's not possible unless, so you'd have to do state management in some other third-party service and then have all of the turrets call that third party. It's almost like the oh my gosh, what's the name? Link, I think, or something like that. On Ethereum that does the state management for a lot of the Ethereum applications for like order books and price guarantees across different assets and stuff like that.
And right now, the current state of distributed databasing, I don't see that. I see that there's things in development. I don't see anything that is out there, production, fast, working.
So much of it depends on the time span of the data. If your state can be pretty ephemeral, like only for one ledger, like that's probably the most important piece kind of that we maybe think of adding next is an ephemeral state, but state management nonetheless for a single ledger. So you have, because the issue becomes if I am going to make a payment or rely on some sort of this will happen, and if this does happen, it would change the state of the ledger in such a way. How can I then, in a concurrent or subsequent request from some other user, rely on that state from that other user to sort of say, well, the balance will change if this succeeds, therefore I need to use that potentially changed state to alter the incoming request in X, Y, or Z way. But because it's stateless, there's not any way to know like what requests have come in before my request that might have changed the sale ledger. If you think of like a donation pool, for example, or a prize pool or something, if 10 requests have come in and taken part of the pool, how much pool is actually left? Well, we don't know because we don't know how many people have come in before and taken some piece of that. So if I look at the current state of the ledger, it says it's all still there. But that may not actually be the case if 20 other requests have come in and taken some piece of that. So there are things you can do to get around that, and it's just by implementing other, like your own state management through some fetch API to some third-party service that everybody calls. But if it's all relying on like your database, is it all that secure? So then you have to start looking at some of these alternative state management, decentralized state management tools that there's not a problem that's unique to turrets. It's a problem in Ethereum, especially in Ethereum where you don't have unbound access to the external web. It becomes a more difficult problem to solve for, and there are protocols out there that are trying to answer that and working on that, and so we may end up implementing something like that. But we're starting small and simple, and we can extrapolate out into more stateful use cases as needed.
What would be a good central handoff if you want to have some statefulness in the data and the way in which you're going to use the functions to interact with that data? Do you think perhaps plugging into a Redis type system might work? Sorry, not Redis, I mean Memcache.
Yeah, any database system could work. It then just boils down to the issue of who owns that and ultimately who can manipulate that to say something that it shouldn't. Because all of a sudden your DeFi platform has a dependency that's centralized, so it's not DeFi, it's not decentralized anymore. Because if the protocol relies on that information to run itself, and that third-party service goes down or becomes malicious, all of a sudden the data that's being used to generate transactions is bad. So the generation and signing of transactions is decentralized, but the variables that decide how to create that transaction, if those aren't also decentralized, you have an issue, which they are if you're using like Horizon. You're relying on whatever Horizon endpoints are available, which I think, again, is why a decentralized, a statefulness would be a good addition, because then you could essentially ask the turret, store this data for me, and then you might have to pay more fees based on how long you want it to be stored. And then each turret that you call would store that data, and now your single point of failure is there is no single point of failure. It's just distributed across the number of turrets that you're using to host that contract. So that's something we're looking at. But a lot of contracts don't actually need any sort of stateful data. It just needs to generate a transaction, and the parties involved are relatively limited. And if there is a need for that, it's just something we'd have to explore. And I think ultimately, as the Turing network grows, there will be different types of turrets that have different pricing models and like uptime guarantees, SLAs, if you will, based on what services they offer. Like, oh, we're a turret that offers a private horizon that you can send custom queries to. We're a horizon that allows you to have a 10 ledger ephemeral state, so 50 seconds or a minute worth of ledger time for doing stateful data, and then it flushes once it's past the time. I don't know. There's lots of interesting things you could do there.
Yeah, one question around this is, I noticed on a NFT conversation that you mentioned auction implementation.
Mm-hmm.
How do you see that working? What would be the overview of technique?
That's a good question, and it really depends on what the required criteria of the auction are. You can actually get away with some pretty interesting auctions using the Stellar DEX, where offers are made such that only a single person could claim them, either with a specific counter token, or they only go live for a specific amount of time, or it's actually like an atomic payment. And I think that's probably the one that's most interesting to me, is that there's a visual representation, there's a UI element somewhere that basically says you can buy this thing during this amount of time, and then transactions get created where there are time bounds on those things, and then once that time bound clears, anybody who makes the purchase first essentially is the claimant. And if you wanted to do amounts, I think Fred from Lightmint has a good post or has some techniques for how he uses the DEX and doesn't even use Turing signing servers to accomplish this. But you're not storing a bunch of offers necessarily in a stateful database. You're kind of just saying this is available for this amount of time, and maybe people are putting out transaction offers, and you might store those on your end privately, but they're decentralized in the sense that so long as they get submitted, you're good to go. I don't know. You'd have to explore it a little bit. Some auctions are more interesting where you get into different pricing models or timescales based off of amount, or almost doing like combined auctions where a group of people can pool money together to be able to make a purchase for something, particularly because these are digital. Stuff like that can work. So many of these things don't have really specific answers. You kind of have to use the bits and pieces. I mean, Stellar itself is non-Turing complete, but it has lots of operations, and just through the nature of its ability to do atomic transactions where you have lots of operations that either succeed or fail together, you can get away with some really clever stuff which maybe wasn't originally intended for that use case, but absolutely does work. So you just kind of have to say, what do we have to have? And then are there ways that we can use Stellar operations or Turing signing servers to accomplish this? And a good way to think about a lot of these things is actually not to think about TSS first. First, you just need to answer the question, how would I do this in a centralized way? Like, what functions on my server would I need to run to make this happen? And then the only thing you have to do after that point to make it decentralized is just upload that function or those functionalities to a network of turrets. And so long as it generates a transaction that needs to get signed and submitted from your backend, it works. So it's better to think of, how would I do this centralized myself, and then to make the switch to DeFi, you just upload those functions to turrets instead of to your server, and handle the logic of the fees that you have to pay and stuff. Like, there are toss-ups, but it's not better, like computationally, it's not better to run this on a turret. The benefit is that it's decentralized, and you're not liable, and you're also not the single point of failure for the network. So you add a lot of trust, which, depending again on your use case, may be really desirable or even essential for your business use case.
Yeah, I guess your input, let's say there's an input which is I'm going to provide money into a pot, so that executes the function. The function then goes to the pot, which is an account, and says, right, how much is in here of this particular asset? Okay, this is here. So if this amount, do that. If it's that, do this. And so there's external inputs that you can use instead of a cron. There's a way of it executing. I guess but you don't have is a built-in kind of timer, but you would just there's always a way that you could bring that in.
Right. So the way that turrets work when they upload a contract is each one of them has an endpoint that the function is accessible through. So if you've ever done any like serverless programming, it's very similar to the way that those work, where you've got an endpoint, an API endpoint that you can hit that will take in any of the parameters that you've set when you uploaded the contract, and then anybody in the world can access that contract. It's just if they need to have the right variables for it to generate a transaction that's actually meaningful. And so the DeFi part is not that it is guaranteed to run at a certain schedule. Anybody can run that at a certain schedule, and if it's important that run at a certain schedule, then either you need to guarantee it or your users will guarantee it. Whoever is sort of in the pool of I really need to make sure this runs at set schedule, then those parties should be running some sort of cron job themselves to make sure that it runs. But there's no guarantee on like the turret side that says this will definitely run. And again, we might think about adding that, but I think again that's kind of outside of the protocol state and into more what's the use case for turrets. And depending on what some of the really common use cases are, there may be turrets that say, hey, we support running cron jobs that will cost this much. So set it up in this way and you can get repetitive tasks accomplished in a guaranteed way. The issue becomes that has to be run again across multiple turrets. Otherwise, you're relying on a turret to run your crons. And as soon as they're like, I don't really care about this contract anymore, your crons stop running. And so you kind of you just got to be careful, again, who you're trusting to run your turrets, because there's nothing secure about a turret in of itself. It's when you add a bunch of them together. It's the same sort of thing with the Stellar network itself. There's security and guarantees across multiple parties doing the same thing all the time. And as soon as somebody differs or turns something off, there's other people to pick up the slack.
Can you dig into that a little bit then, in terms of how it's replicating across the turrets? So this has been developed completely independently. The code base is separate from Stellar in every sense, and then interfaces with Core.
It interfaces with Horizon, or really just interfaces through the SDKs right now. The reference implementation does. The Stellar SDK. So it's just interfacing with Horizon. So you kind of just build a contract, a TX function, and then upload that to as many turrets as you feel like you need. They send back a signing key that you then add to any account in question. Maybe that's a pool account or a donation account, or maybe your own personal account. There's an interesting example of doing like balance checks on payments. So if you had like a wallet that you wanted to like help yourself save money, and so you only wanted to be able to spend $100 a week from an account, essentially you would maybe upload that to just 2 turrets that do a check that say, hey, let me take a look over the past 7 days and see how much money you've spent. It's over $100. We're not going to sign for this next transaction. And thus you could kind of create a limit, some signals and blocks and checks on an individual account. And so it's really only benefiting perhaps you, or maybe you build a service where other people can use these different TX functions that provide different limited sets of functionality to signing for Stellar transactions, but it's not this big universal, everybody uses the same account. You add the same signers to lots of different accounts, and then depending on, hey, I'm talking when I send the request to the turret, I'm talking about my public key. This one has this account. spent more than $200 or $100 in the past 7 days. If it has, don't sign for the incoming transaction. So there's lots of different ways you can use these things, but again, it's best to kind of think of it in terms of how would I do this centralized first, build that function, and then just upload that to multiple turrets, add those signers that they send you to your account, and then you have the whatever the multi-sig setup that you need, you have that available to you through those turrets, where they actually now have like signing power over your account, but together as a group, never as individuals.
Yeah. So the summary is upload your TX function or functions, and the turret gives you back a key, and you can then use that key to go and execute the functions you uploaded across the turrets.
Essentially, yeah. So turrets will generate transactions along with a signature for the transaction, and that signature will be valid for that transaction if the transaction operations, the source accounts that are affected, have the signing key from that contract, from that turret, added as a signer. And it might be helpful if we walk through just some really simple examples. I actually have a contract. Yep. Let me jump into this right here. We've got some.
Can we make that a bit?
Yeah, I am. I'm gonna grow that just a second. How's that?
That's great.
So I've got a TX function right here. So this is the code. This is the string of code that you would upload to an actual turret. So you would just write a function that has a single export. The body is going to have the pieces of information around any parameters that are coming in when a request is made to this specific Contis TX function, this contract. And I think the only thing that this one is doing is taking in a destination and a source. So it takes in a source account right here. It looks that up on the Horizon. In this case, that's hard coded to the Horizon testnet. Takes that account, builds a transaction for that account, so that the source account is the one that's going to pay the fee and also pay this one lumen, this asset native lumen, this one lumen to the destination account. So it's just a really, really dead simple payment contract where you basically say, hey, here's my source, here's my destination. I would like to make a payment from the source to the destination, generate this transaction for me. But most importantly, when it comes back, it'll say, okay, here's the XDR, but I could do that super easy. There's no reason to do this in a turret except for it will also produce a signature. And so long as I've added that signing key for the signature to this source account as a signer, then anybody who calls this TX function can get themselves one testnet lumen. Again, you would probably never want to actually put this out on the live network, because now anybody who knows your source account can immediately just start instantly forever paying themselves one lumen. Which, again, that's very powerful. That's very cool, because there's never been a time where you can do something like that or make something like that. But it does mean you have to be pretty careful when you make a contract, because as soon as somebody finds it, or a TX function, as soon as somebody finds it, if you haven't built it appropriately, they can execute and build whatever transaction you've said they can build. And in this case, it would be for source. Now, you do have to add the signing key that it gives you back to your actual source account. I think I might have already uploaded this contract, so it might already be available, but let me pull up my Postman so we can make a actual request. I will, big disclaimer, I've been working on the protocol a bit and I haven't worked on it in a while, but I worked on it quite a bit a while ago and haven't had time to go back through and test everything. So there is definitely a chance that we will get into some fun times. I'm going to try and get this to pull up for me. Is there a way to... There we go. Actually, I'm going to keep that open. Make this bigger again. So we've got our TX function upload.
Can you make it a bit bigger?
Yep. Let me just go ahead and make this full screen too. How's that?
That's great.
Super. So right now if I call, so I've got an endpoint right now that is my turret endpoint that includes a bunch of the get endpoint on this turret includes some information around the turret address. So this is the address that payments will be made to. Any sponsorships for TX functions will go there. It tells me the network that it's on. It tells me the Horizon endpoint that it's using. There's a runner. So this is the actual where the TX function is actually run. I use lambdas to run those, isolated lambdas to run those because it's running arbitrary JavaScript. So I isolate it completely. The version that it's on, the fees that it's using. These are divisor fees, which we don't worry too much about those right now, but it's essentially these numbers dictate how much money it costs or how much XLM it costs to actually run or upload transactions, TX functions.
So can we just dig into that a second? So sorry, the divisor, you're saying 1,000 or what have we got there? 100,000. That's the that's going to be the cost of running a TX function?
No. It's the divisor. The divisor is the number that's used to generate, to derive the cost of uploading or running a TX function. So it's based off of runtime. So if a TX function is very quick, it takes the number of milliseconds and divides that by the runtime. So if your TX function takes 1 second, 100,000, and then you divide that by the divisor, that's the number of lumens it would take to run that TX function.
Got it.
But these are variables that aren't set in stone, so these are just arbitrary ones that I use. I have no idea what will actually make sense in production. It'll take time to run analytics on the side of the service, the TS service provider, to figure out how much money it's costing them to keep a turret up, to determine what these numbers should be. But they're just variables that are made available to TSS, to turret function, to turret service providers, so that they can make sure they're covering their costs in a pretty fine-grained way. But these are the ones you can. It's available at the get endpoint. So if you can essentially say however many milliseconds you think it's going to take to run a contract, it's going to be divided by this. The upload is actually taken off the number of bytes that the TX function size is. So if your TX function is 100,000 bytes, it would be 100 lumens divided by 1,000. It'd be 100 lumens to upload it. Most of them are a bit smaller than that, but and that's a one-time fee to upload a contract.
In terms of running turret costs, we're looking at pretty well Lambda only, because Cloudflare is $5 a month.
Yeah, something like that.
The cost seems to be low. Lambda, I haven't personally got much experience of costing on Lambda. Have you got any kind of finger in the air ideas of the execution costs on Lambda around the lifespan of a smart contract function?
Seems to be super, super cheap. You had 1 million requests for free. And that's on pretty high memory. Like, it's like a gigabyte of memory for. They charge based off of the number of milliseconds that your Lambda runs, based off of some metric of the amount of memory that you're using or that you have allocated to the Lambda. But there's other costs that come involved with that. If you want to reduce cold starts, where it has to spin up the whole application, you have to provision some reserved concurrency. So if you're choosing to do that, there's going to be some higher costs. But overall, it seems like it's going to be very cheap. But again, it's going to be a metric of how much, how big the code is that you're sending, how long the functions are running for. If on average functions tend to be really, really simple, it's going to be very cheap to run a turret, unless your contracts are getting called 100,000 times a minute.
Yeah. If you've got a cron on it, for example.
Right. But again, the idea should be, so long as you're getting paid for every run, who cares how much? Like, yay! If it runs 100,000 times a minute, I should be getting rich, even if it costs me $100,000 a month. If I'm making $200,000 a month, and whoever's hitting my endpoint 100,000 times a minute, so long as they're okay paying it, I don't care. But it will definitely be cheaper than Ethereum, because you've split up the running of this thing. It's not running all over the world. It's only running on a very limited set of turrets. So your scope is already incredibly reduced compared to the costs that you're going to see on Ethereum. Plus, most of the contracts that are running are much simpler, because you can delegate out. You're not actually executing the contract or executing the XDR on the turret. It's just generating an XDR, and then you take that XDR and actually submit that somewhere else. So it's separating out the logic between Stellar transactions.
A question. You mentioned different pricing models for different turrets.
Mm-hmm.
How does that work out in a when the user is saying, right, let's execute this, let's send it off to a group of turrets? How are they going to be grouped by in a kind of pricing band? What's how would that work?
I think we're probably going to land on like a tiered model that sort of says your base tier turret that doesn't have custom horizons. I don't know, because a lot of it's going to depend on what features people need for turrets and what they're willing to pay for those, and how much it costs. Like, how much does it cost to run your own private horizon? Depends on how much history you need and what endpoints you need active, what kind of load the horizon is getting. All of that's going to determine how much money it actually costs to set up a private horizon, to be able to offer that for your turret users. So it's gonna take a lot of time, I think, before we arrive at what those tiers are. I do think it would be nice to have clearly delineated tiers, so you can say, okay, I'm writing a contract that's going to need to be uploaded to a tier 2 turret that has custom horizons, or has an SLA, or isn't perfectly public, where I need to do authorization for my contract so that not anybody in the world can access them. But each of those will come with its own set of costs. I have no idea what those costs are going to be at this point, because I don't know what the features necessarily are. Right now, we're starting with the very base, simple use cases, and then kind of building as people address or recognize requirements or needs for themselves and their use cases. I think there will kind of filter out to be I don't really need anything special. I'm just going to keep using as is. I really need some really simple state management. Okay, well, let's at least start a tier. We'll start a tier 3. Maybe that's our base, and then we build up from that. Where you just say this is where we all start, and then as we add new requirements, we can build up from there. But it'll eventually come down to hitting this get endpoint on a turret URL, and then slowly over time, this will get filled up with more stuff that sort of says, hey, I offer a private horizon. Mm-hmm. So you might see higher fees, but you get a private horizon. And then in the documentation, there'll be, what does that mean? That means you can send these requests. So the protocol will kind of update itself as new requirements come, as we say, okay, we definitely need private horizons, and if they run them, that means anybody who runs a private horizon needs to support X, Y, and Z functionality, so that anybody that requires that can upload it to contracts or upload it to turrets that say they have it, so that the same contract that they're uploading to each turret that they require private horizons on will work exactly the same.
Yeah, there's a opportunity for someone to create a almost a smart contracts as a service,
Yep.
as a layer over the top of turrets to then offer, here's an easy way to get the contracts that you want or the functions that you want, and provide that out to people so they don't have to dig into complexities of coding it.
Yeah, turrets. Yeah, I mean, it's the same sort of thing on Ethereum where you've got companies that
Mm.
specialize in writing Solidity or auditing um, Ethereum smart contracts. I think you'll see a similar thing. I also think you'll see um, uh, business models rise up for actually adding additional functionality. So here's a service that you can add to your turret that will give you private Horizon functionality. Just run this Docker container, and you immediately can level yourself up to a level 2 turret. Um, here's a package that you can install that will add stateful management to your turret. And so essentially you're a turret service provider with different plugins that you've added. I mean, it kind of becomes the WordPress model, right? Where you've got a protocol base WordPress, and then all these people build plugins and widgets and stuff on the side that will customize your experience for whatever the needs of your users might be. Because I also think like it's a protocol. It's nothing about the protocol that says it has to even be fully globally decentralized. You could say we've got an organization and we don't want any of the execs to have full control over the system, so we're going to create this private network of turrets that coordinates signatures for payroll. And it's nothing fancy, it's nothing global, but it really helps our internal bookkeeping to have these things run by computers rather than, or have them run by machines that nobody directly has access or control over, that then coordinates how decisions are made or how payroll is done or however it might be. I mean, even decentralized organizations would be really cool where there aren't execs who make these decisions. You have it contracted in how raises happen and who gets paid what salary, and you essentially use turrets as your organizational management. And instead of it being this large network of who knows what kind of contracts are getting uploaded to this thing, we're only going to allow contracts to be uploaded that regard our organization. And so you essentially just take the protocol and use it for whatever needs you have. There's nothing that says it has to be used where anybody can upload anything at all. Which I also think is where sort of a tier 3 might come from with service license agreements, SLAs that say we guarantee 99.99% uptime, stuff like that. Oh, I just lost. All right, there we go. Sorry, lost Steve from the meeting.
Sorry about that.
No worries.
Technical issues.
Yeah, essentially where there's service license agreements that say we don't allow anyone to upload anything. If you pay us $20 a month or $5 a month, you get an SLA agreement. You can upload private contracts to our system, and you get an agreement with 5 of those turrets across the globe. Your costs will still be quite low, but you'll be guaranteed to not be running. I mean, it's almost like private Horizon endpoints. If you sign up for something on like Blockdaemon or something, you can get a couple of private turrets and be guaranteed of uptime or faster speeds or lower rate limits, higher rate limits. It's kind of a protocol that is now going to grow into an ecosystem.
In terms of the redundancy, when you execute, I'm still thinking about the that different in pricing. We've got 2 turrets. One is priced low, one's priced a bit higher. When you execute, you're going to execute against the runner URL.
Yep.
But when you do that, let's say this turret's gone down, how does it then redirect to a different turret?
That would be up to your own contract logic. So probably what you want to do in your multi-sig is not require all of the turrets to be a signer. So you might do like a 4 of 6 or a 3 of 6 multi-sig where you only need 3 signatures of the 6 that you've uploaded to. You'll only pay for the ones that you actually run, that successfully run. But if for some reason one of the 3 that you're initially calling goes down, you still have 3 others that you can call until you get that third. So you now have a 3, you have the sufficient weight to reach your threshold for whatever the transaction you're trying to execute or whatever the operation that you're trying to execute is.
Okay, so your script is going to explicitly send the same request to 3 servers.
Yep, exactly. And that happens on the client side. So if you're like in a wallet or something, you would basically say, try these 3 turrets. If one of them fails, like here's our collectible. Well, probably what you do is we might like maybe eventually make like a turret SDK or something to obfuscate some of the stuff away from everybody having to replicate it. But essentially what you probably would say is, here's the contract I want to run. Here are the 6 turret endpoints. Just start calling these in a series, or maybe even call the first 3 of them in a promise all. And then if one of them fails, retry with one of the remaining 3 until in a singular loop until eventually one of them succeeds. Or if it's not that expensive, just call all 6. And then if 5 come back, just pick at random. It doesn't matter now. Just pick 3 of them and run with it. Depending on your scale and cost, that may not be a great idea, but it could be a way to speed at least the request. It depends on what you want, cost efficiency or speed efficiency. And
from a security point of view, what do you think the minimum is?
I don't know. It really depends on the contract. Like the minimum is 2. I mean, technically the minimum is 1, but then you're like, why don't you just run it on your own server? Yeah. 2, but then you would have to include, well, interestingly enough, you could do 1 and then add yourself as a half signer on your own account. So now the turret is signing for 1, or signing for, like if your weight is 2, I'm sorry, if your threshold is 2 and the turret's weight is 1 and your own key weight is 1, you can't sign for anything, the turret can't sign for anything, but both of you together can sign for something. So you don't necessarily have to give control over exclusively to the network. You can leave yourself as the final signer if you needed to. So you could do 1 turret. You would just want to include yourself as like the last turret that isn't a computer. You're just, finishing that last signature or something, which might be kind of cool. Like, again, that might be that payroll thing. The last signer might be the execs, but at least the execs don't have complete control to pay themselves $1 million if they wanted to run away to Tahiti. They just are the last signer to ensure, okay, this all looks good. I'm signing off on this. And maybe 5 execs have the power to do that, but no exec has the power to actually make a payment themselves. But there is like some human at the end of the chain. Again, you're completely up. It's up to you how you want to coordinate the signatures and the thresholds and the weights. It's just now you have a programmatic way to create transactions and to use signatures to your advantage in whatever scenario makes sense for your own use case.
Great. Yeah, makes sense.
Cool.
So the uploading a function, then we've got just one thought. I was thinking about on Postman, you can export projects, can't you, in terms of the functions? I don't know if you could share your TSS.
That's
here.
A good idea. Yeah, I hadn't done that yet, but I definitely could.
It'd be a fun way for idiots like me to be able to play.
Yeah, it would be pretty easy way. There are definitely some things that get a little tricky around creating the authorization tokens when you're actually running a contract. You have to generate a specific authorization token that allows you the permission. So to be able to generate fees, you don't actually pay fees on every single run. You actually create a claimable balance. It's like a prepaid credit card kind of, or debit card, where you prepay a claimable balance to a turret, and then they slowly rack up payments against that claimable balance until a specific time point is reached or the balance is run. So if you have a claimable balance of 100 lumens, once you've used up 100 lumens, it will execute that claimable balance and claim that into the turret, and you trying to use this token again would fail. But generating these is not something that Postman can do. You would have to generate this outside of Postman.
Right.
So there are some pieces like that, but just having the endpoints would probably be helpful. Yeah. So, what do you think would be most helpful? We've only chewed up through about 1 hour so far.
No, we got lots. Don't
So,
worry, I got lots of questions. So I mean, first, it'd be great to let's upload a function, and would love to be looking at the log, checking something has happened, because I think from a application point of view, there's obviously a few different stages. At first, getting the function, getting the contract into the turret. Secondly, executing it.
yep.
Looking at what's happened, being able to query to give some user feedback, and of course, you would a little bit difficult because we're talking about not having state stored, but with more complicated contracts, you would be looking to query and find out what the current status of a contract is. I know we can't really do that today,
Right.
but
So it's not
certainly
so much
looking
like
at
the
the log
status of a
is good.
contract. It's more the status of the ledger or an account. So you do have state. It's just not state
Yeah.
inside a turret. It's state inside Horizon or state inside some other database somewhere else. And that can be another decentralized database.
Mm.
Particularly if you're looking up like price information. Coinbase has oracles, and Chainlink has a lot of different oracles. So there's information that doesn't have to be centralized. It's just like, where is it stored? Right now it's not stored in turrets. Eventually I might like to look at adding it, but we just have to make sure we get it right. But let's go ahead and any questions on that?
No, not at all. I guess my reticence for pushing Horizon too much is I don't want to. I don't like the idea of hammering the Horizon APIs.
Yeah.
Prefer to put that sort of load somewhere else.
There's always going to be hammers to the Horizon API, even if the only thing is submitting transactions. What really needs to happen is not relying on a single Horizon endpoint. So Horizon is just a server that connects to the core and runs its own digestion engine that turns the XDRs into JSON endpoints. But I think turrets probably need to set up their own Horizon endpoints, so each individual turret is relying on its own individual Horizon. Right now, you can set your own, like if we looked at our turret details, you can set your own Horizon endpoint. Right now, I'm just relying on, the testnet on stellar.org. But that could be anybody that's running a public Horizon, or if I stood up my own, even if it was private, I would change this Horizon endpoint to be that. And then any queries that you make when you call Horizon, you would use, instead of using the public Horizon or Stellar's Horizon, SDF's Horizon, you would use that turret specific Horizon.
Yeah, great.
So then you wouldn't have to worry about those overloads. And it could also eventually provide custom functionality for queries that, particularly if you need to like go through an account's transaction history or something, it might be nice to be able to filter by memo, or only look between specific ranges, or only on amounts that were over 100,000 lumens, or for this specific asset. Like all that filtering would be nice to have, but it's not available on the current Horizon implementation. But if we had custom Horizons, we could kind of write whatever logic we wanted to for our own private Horizon. So that would be cool. And I think eventually, particularly before we go to production, that kind of thing will be pretty important for production level Horizon use cases.
So let's execute this simple hello world contract.
Super. So I'm gonna excuse me. I'm gonna look at this one here. I think I might have already uploaded it, but we'll just go through the process of what uploading this would look like. So usually what I like to do is actually use, I'm going to pull up another window here. I like to use RunKit to run like my contract logic while I'm building it. So if I'm building a contract, I like to use RunKit. If you're building a more complex contract, you can do it in any JavaScript SDK or code editor, whatever you have, IDE, doesn't matter. Anything that works. We have a couple of global variables available to us. So if we go back to our code and we go to serverless source app, there are a couple of global variables that are available to us. So we don't have to, when you're building a contract, it's a single executable file. So any dependencies have to be bundled with the final executable.
Yep.
So you can use something like Webpack or Rollup to get it into a single format. But if you don't have to use dependencies, that's best. If you do, you have at least a few global dependencies that you don't need to bundle up. The first is fetch. So I'm pulling in node fetch for you. So all of your HTTP external URL web internet connections, you can use fetch for that. We're also pulling in Stellar Base. So we're not pulling in the Stellar SDK. We're pulling in Stellar Base, and the reason for that difference is Stellar SDK pulls in a lot of the like submission information and actually making queries. So if you need to query an account for its state, you need to use fetch, not the Stellar SDK. Stellar Base will be good for like composing transactions. So you can look at the Stellar Base documentation to see what's available and what the differences are between that and the SDK. The next one is big number, so that we make sure we get our numbers formatted correctly so we don't run into math issues. These are kind of the most common that I've found people using. So those are the ones that are provided. We may end up including more as time goes on, but those are the global functions or packages that you have available. And then you also have two variables. The horizon URL is a global variable you can use. So this is the one you're going to want to use instead of, unless you literally want to ensure you're always calling a very specific URL. If you want to use the turrets horizon URL, the one that they've set in this get call here, if you want to make sure you're using this one, the turret specific one, you'll call the horizon URL. And then also the Stellar network. That guarantees that you're using this right here. So either testnet or pubnet or whatever the network is, so that you could set the appropriate network for the turret that you're calling rather than hard coding it. So those are the pieces that are available to you globally. Now, if you're building this not in a turret, you'll need to include those as actual require. So we'll comment that piece out for now and do require Stellar Base. And then the body, that comes in from, when the request actually comes in from the module exports, which we just removed. This is the function that's being called. The argument that gets passed, the only argument that gets passed is the object from the body request. So when you actually go and call a TX function, inside of this body is an object, and anything in this object will end up as a variable or an argument inside of this body argument. So like if I set the source or the destination, they would be available to me in this function. In our runner here, this would probably be request.body, which I need to look up my endpoint. So RunKit lets me build a really simple endpoint, but I don't remember exactly what it was. Exports endpoint. Let's try this. And then we would put all of this inside of this. And again, this is just like constraints of using RunKit. If you were building your production level contract, you might use something different, but Then we take our source. So we actually are going to put this inside of this. And I think I'm actually going to do this request and response. I think it might need to be destringified. I'm not actually sure. Let me do a quick res.send on the request body. So this is something that's kind of nice with RunKit, is we can then view our endpoint on this and start to get back errors. Let me do this really quick. Make sure I've actually set this up appropriately. Oops. Maybe it's not res.send. There's another one that used Express. Let's try. Express really quick. Been too long since I've
Well, I was just going to say kudos to you for live coding.
Yeah, exactly. Something like that. All right, so we've got that piece working. Let's now try this bit. I also need to include, oops. This, I think. Wonder if they're using an older version of Express, where it doesn't support that JSON. All right. Well, ultimately we don't actually need, I'm gonna skip the endpoint piece just for now, rather than try and fiddle with all that.
And if you've already uploaded it, we could always just execute it, so you don't have to worry about the upload part.
I do want to highlight just that it puts out a XDR based off of inputs that you're putting in. So, but I'll do this instead. We'll do source, and then that needs to equal an account, and then also, what was a destination? Why type when you can copy? We'll go to laboratory real quick and just generate those, which I do think these, well, it actually will probably work just fine. I'm going to make a payment to myself at the moment. I think it'll generate those just fine. It wouldn't execute.
Okay.
See what we get. Must have missed. New transaction builder. Aha. All right, so that should produce our new XDR. Whoops. I think it's producing a fetch because this is node. Well, yeah, this is just a waste of time at this point. We should have, ultimately this one does work. Take my word for it. We're using our global variables here. And then the way that we'll upload this is going to turret TX function upload.
Yeah.
And I'm going to grab the TX function file. So this is using the form data body type. Let me go back to my code and reveal this in Finder so that I can grab that without having to look for it. So that's our file. Now the file takes a TX function field. So this is essentially answering the question, what fields is this TX function, was this, yeah, TX function raw. What is that expecting? What fields is that expecting? And essentially what you do is you take an array with objects per field. So you say there's a name, the name is destination. So that would be the argument name that's expected. Mm-hmm. What type is it of? In this case, it's a string. And then you've also got a description. So some information to deliver to the user to say what's expected here, and then a rule. So if there's an exception, like they pass a number or it's not an actual seller address, something like that, you can send an error message through the rule. So you just have some variables there, or some key names there to send to the user. You then take this and you turn it into a JSON string. So if I pull up this guy right here, we'll look in our console just so I can make that a little bit bigger. If we take, let me just take this object here, or this array, we're going to JSON stringify that. And then what we need to do from there is turn it into a base 64 string. So B to A. And that will give us the string that we use inside of the TX function fields. Just gives us a nice compact way to deliver the TX function fields information.
Yep.
And then the last thing you need is to pay the fees. So if we exclude the fee on our first attempt to send, this might error out because it's already been uploaded. It has. So I'm actually going to really quickly go into my Cloudflare account and delete that TX function fee or TX function so we can upload that brand new. So give me 2 seconds.
Okay.
Shouldn't take too long. Go to my workers, key value, TX functions. What was the name of that? AEOB. There it is. All right, so now that's been deleted. So hopefully when we try and upload this again soon enough, it should let us. The key value has a potential 1 minute latency, so sometimes it can take just a second for that to clear the key value cache. All right, let's try this again. All right, so it failed to process the transaction fee because we did not make a payment, and the cost is that much. So to upload this function, we need to make a payment of this amount. So what I need to do is, this is the turret that we need to make a payment to, so I'm going to go to the Stellar Lab. I'm just going to arbitrarily, it doesn't really matter who it comes from, just so long as it's going to the right account. So I'm going to just go ahead and fund this account, make a quick payment for, or to this account, payment to the turret for this amount. And the source account was that. We got our sequence number. Everything should be good. Now we need to sign that. Now we don't submit it here because we need it as our TX function, or as our TX function fee right here. So we paste that in and we try to resend. That's going to go to the turret. It's going to read that and submit that transaction. So long as it's for enough money, it should all go through. Looks like it failed, so that's not great. I wonder, let me try increasing my base fee just in case that was the reason. I'm also just going to increase that to 1 for now in case there's some issue with fees not going through. I don't know why that does not work. Let me really quick look at the source for TX function uploads. I may have changed something on the upload piece. Oh, I know what it is. Our testnet was reset. So this account doesn't exist yet. My turret account is brand new. So let's fund my my turret so that I can actually. So what's the failure that's happening right now is it's trying to pay an account that doesn't even exist. Debugging live right after a testnet reset. All right, super duper.
There you go.
We got it. So now we've got a hash, and this is our signer. So this is the piece that if you wanted to be able to use this contract on an account to get transactions signed underneath the parameters of the contract, you need to add this signer at a sufficient weight for the operations in the contract to actually sign for. So I'm going to go ahead and do that.
Quick question. So that signer coming back, are you going to use the same signer across different turrets? Or you're going to send the contract to say 3 different turrets.
Exactly. So I would change the URL here.
Okay.
Make sure I get a new TX function fee for that turret, and it's going to give me a new signer.
Yeah. Okay.
For our use cases, I'm just going to include this one. I'm going to do the same account, which what I'm going to do before I forget the secret key of this account is actually write this down.
Yeah.
All right, so this account is that. We'll go ahead and bump our sequence number, which we already did. And I'm going to set options and add. Actually, I'm going to change the master weight. So I'm going to. I don't really want to accidentally lock my own account out yet, so I'm going to leave that. What I am going to do is set the master weight to 2. Actually, we're going to leave this at 1. All of these is 1, and then the signer I'm going to add in this case, which is this right here, I'm also going to put this as 1. So now this turret has complete signing power over my account, which is not ideal, but in our use case where we're only uploading to 1, and I don't want to lock myself out just in case I need this account later to change something, I'm going to leave everybody set at 1. I could leave these thresholds at 0, but just so I'm sure I know what I'm doing, I'm going to set them to 1. Sign this again, submit that. So now if we explore this account, we should see that we have 2 signers, both with a weight of 1. One of those is our turret, and all the thresholds are one. So both of these accounts can now have full signing power over this account for any transaction.
Great.
All right, super. Yep. Now what we need to do is actually run this transaction. Or actually, let's so we uploaded, we got this hash. Let's get this transaction so that we see what information actually has. So the function includes the string of the actual contract. So this is the code that will be run. And then it also decodes the fields that are required for us.
Yep.
So we could send this back to a user, for example, to say, hey, these are the fields that are required on this. And then also the signing key if we ever need to get that and upload it again if we forgot or even need to clear it at some point in the future. We know what signers associated with this contract on this turret. So the next piece is to actually run this. And this is the piece that we recently changed because we had a different way of paying turrets. So fingers crossed this actually works. We want to I'm actually going to call it on this one, which we changed this to be just that. Source and destination. Let's set our our parameters. So this is the contract. This is the contract hash for the contract that we just uploaded. We'll worry about the authorization in just a moment. Right now I'm going to say let's do that again, that payment from ourselves to ourselves for whatever that contract said, which I think was 1 lumen, right?
Yeah, 1 lumen. Yep.
And now we need to figure out how to set up our authorization token. And this is the piece that we changed not that long ago. So I actually need to recall myself, which I actually think I have a run kit for generating these. So let me look that up really quick. Give me a second. Because these tokens are a combination of the sponsored sponsor, what is that called? The claimable balance. Oh my goodness. So you take a claimable balance paid to the turret and then combine that with instructions for what turret it's allowed to run on. Where is this thing? That's an example. I might be able to use this one. I'm not sure. I'm guessing this one
is it
probably won't.
The logic for using a claimable balance is that if it doesn't run, you can return the funds? Or
no, well, sort of. The claimable balance is that when you're running... oh, interesting. I guess I haven't... Huh. When you're running a lot of... So to be able to run contracts, you have to pay fees to the turret. But if you're running at high concurrency, it's not... There's no feasible way to be able to make an actual stellar like microtransaction for every single execution. So there has to be this concept of like slowly storing up. It's the only, like, if there is a state inside of turrets, it's this state where you're slowly keeping track of how much a user owes or how much a particular executor owes to the turret for running contracts.
Yeah, so you aggregate the payment.
Right, exactly. And they're very small. Like turrets, it doesn't take a lot of money or it doesn't take a lot of XLM to actually execute. So you just bundle up and you set a limit. You have a cap on the actual run to say I'm only going to run for this much. Either I think it's like my limits are 1 to 10 lumens or something like that. And it doesn't look like I've actually made the change, so it might actually work still underneath this one. But essentially, the user's liable or risking, I guess, like 10 lumens to run a contract, and the turret is risking that they're actually going to be able to claim the claimable balance. We were doing actual payments where it was an XDR that was pre-signed that the turret would submit at some point in the future. But the issue was, what if that valid transaction didn't have enough lumens in the account when it was time to submit the transaction? The claimable balance sort of fixes that issue on the turret side, where essentially the turret has the lumens, they just haven't actually pulled them in. It's that two-part payment where the user has relinquished control over access to that payment, but the turret hasn't yet claimed them until they've reached the user has spent up that many tokens.
Yep.
And then they claim the balance. If at some point in the future, I think it's set at like 6 months or something right now, the turret like dies, goes offline, for whatever reason doesn't claim the claimable balance, there's a predicate on or a condition on the claimable balance where the user is allowed to reclaim their own claimable balance after that certain date. So that, again, there's a recourse for the user to get their lumens back if for some reason the turret doesn't claim those after that amount of time, or they haven't burned through that many. But it doesn't look like I've changed that yet. So what I might need to do, I thought I had, but apparently I had not. I just need these pieces. We'll try and run this underneath the classic. So right now, the old version of this didn't use claimable balances. It used the same sort of thing that the contract upload used, which you can execute transactions immediately for contract uploads because they tend to be for more lumens and they're also lower frequency. Which is fine for the TX function uploads, but for the TX function fees on contract runs, they tend to be for much lower amounts of lumens and also higher frequency. So there needs to be a new method for doing that. Let's see if this actually, what this errors out on. All right, nice. So let's try and make a payment again. So going back to our, this is going to require all of the sponsor stuff too. The other reason we moved away from this is you actually need to add sponsored accounts, which adds a whole nother layer of complexity. So the claimable balance thing is really nice to not have to mess with. But let me see if I can really quickly spin one of these up. I might already have a sponsor, so let me delete that and just try and create a new payment to the turret for 10. And you'll notice these min and max fees, min being 1, max being 10. It will only accept liability for a payment of up to 10 lumens, so it won't take liability above that. And if you are like, well, I'm not paying 10 lumens, that's crazy. Or if the max is like 1,000, you can always go down to the min. So it's kind of a threshold for both the user and the turret in case something happens. This is the max you would be out, or the min that the turret or the user would be out. Let's get that signed by that user. Now, the only question might be that the sponsor does not... Actually, I've got a sponsored account, so let me... Don't worry too much about this particular piece because it's all outdated since we switched over.
Okay.
But I think I have a controlled account. No, I deleted all those, so I'll have to make a new one. But let me go ahead and get this piece, because that's our TX function fee for actually running this. And that goes here. And I'm guessing this will error out on a sponsor. So we need to go and do a TX sponsor add. And looks like our contract here. So essentially the way this worked was say, I'm going to make a new sponsor. which is exactly the same thing we did when we uploaded a contract that said, but I'm also going to only allow it on these specific contracts, which our contract is included there. So I'm going to make a new tab and build a new transaction from this account, making a payment to our turret again. I think it's 1 lumen for this. We'll get that signed by the secret key of that sponsored account. So now the user and the sponsor are the same person, which again probably wouldn't be what you would want, but it's fine in this case. Oh, I didn't want to submit that. I need to submit that on the actual turret right here. Go back to here. This is the TX sponsor fee, and this is what we would use to actually get the sponsor added. Missing or invalid TX sponsor fee. Oh, it costs 10. Not 1. Which again, we're not really using TX sponsors anymore, so. The claimable balance, again, there's lots of reasons to switch. One of them was to get away from this TX sponsor nonsense. Just because we have to be really careful of letting people farm sponsorships or farm I don't remember what the memo hash was for. Hopefully I don't need that. We don't want people to be able to just spin up random TX sponsor fees and like merge the account away or something like that. So the claimable balance gives the lumens to the turret. They just haven't actually claimed it yet. So it works a lot better. So that was a really nice improvement. All right, let's see. This sequence number is going to be invalid now. So let's get a new sequence number, generate a new payment. I think I might need to use, I think the memo on this might have been what I needed. Let's see what happens when I try and submit this, because I think what I need to be able to get this is the memo. So when I generate the transaction, I think that memo piece, when I did the TX sponsor, I think that needs to go right here. Fingers crossed that will actually work.
Yeah.
Not there. Here. If it works, this should send back.
It wants to work.
Yeah, it wants to work. Cannot read property length of undefined. I wonder if one of our accounts has not been created. Essentially, if it was working, what would come back would be an XDR and the signature, which we would then add to the XDR and submit it. I'm going to try just a little bit longer to see if I can figure out what length of undefined is. My guess is it's either something on the contract. The errors here, we need to work on getting better like stack traces on where the errors actually came from.
Yeah.
Because it sends out errors, but they're not all that helpful. It does look like the error did come because it went to the actual Lambda. It does seem like it came from the contract itself, which probably means that we have an issue on this side. And for this, like to actually be able to fix this, you would need a new contract, which is why it's really nice to test all your contracts before you upload them. So either there's an SDK change. Let's go ahead and use this contract. So this one actually goes to a run kit. And what that lets me do, you would never want to do this in production, but it goes to a run kit URL and actually executes code from a run kit. Mm-hmm. So that means that the contract is mutable. I could just go into this run kit and change the code that this is running.
Yeah.
So this might be a better one to actually try and run. So let's go back to our upload. And instead of uploading the raw, let's upload, because it's the exact, right now anyway, it's the exact same contract. And so that is the contract hash. So if we try and run, if we go to our parameters and change, oops, this is running the wrong, contract hash. I hadn't switched it over from, this is our contract hash. So maybe that was our problem. We need to run this contract. I was running the wrong contract. Hey, what do you know, it works. It's amazing when you get the variables right, things just seem to go okay. All right, so super duper, we've got our XDR, the signer account, which is what we expected, that account that we originally added. We've got a signature and how many lumens it cost us to run this transaction or to run this contract. So what we need to do now is, this is an unsigned XDR because you don't want to add the signature to the XDR, because depending on what your multi-sig scenario might be, you might have a bunch of signers that you need to add to the XDR. So we just provide the unsigned XDR here and then include the signature itself. And so I've got to actually get this into a state where it could be submitted, right? Because we only need this one signer. I've got a helper tool here for adding signatures to transactions. This is a piece that you would do on your end. So as you get all of these different turrets producing this same XDR with different signatures, right? I'm going to pull this up over here. You would essentially take the XDR here, pop that into this piece. Am I not allowed to edit this? Oh, it's just messed up because the size changed. Let me make this a little bit bigger. We'll paste in our XDR and then the signing key, which was this guy, right? Wait, this is verifying transaction signature. This is not actually adding my signature. Hold on. I need the one that actually adds the signature. Which you might actually be able to do that. Yeah, here it is. This is the one. Make that just a little bit bigger. So we take our XDR, swap that out. We get our signer, swap that out, get our signature, swap that out. So basically in your code, you'd probably have like, you'd have the same XDR and you would make a check to make sure, like, okay, give me all of the responses that have the same XDR, and then loop over each of those to get the signer key and the signature, take that XDR, whatever network that it's supposed to be on. So put that transaction in, and then add the signer key with that signature and add it. And you would just, do that however many times you have signatures for, and then you would finally produce that that last XDR, which would be this guy right here. And then we'll clear this. Oh, we already signed it, so now we just need to submit it. So with any luck, this payment, you can see right here, we've got that 1 lumen payment that the contract built for us. Payment from and to, same account. So with any luck, when we submit that transaction, it'll actually go through from a fully signed, controlled turret account. And it did, so super duper, that worked fantastic. Another interesting thing is you could actually change, if I'm not mistaken, which I, never am, if you change your source and destination, you should be able to get a valid XDR. I guess the account doesn't exist. So let me create the account really quick, because it actually tries to load in that source account. You could load this in with any account at all. You just change the variables on your source and destination. The issue is if you added the, so if we go back to our run kit really quick and we swap out our XDR, with our new signer and our new signature. This is going to be signing a transaction that it does not have a valid signature because we didn't add the turret to this source account, so that won't work. But the turret doesn't care, right? It just takes the source, the destination, and spits it out. What matters is where was the turret signer actually added to. If we wanted this to actually be valid, we would need to add this signer to this, in this case, this source account, right? Because that's the account that's in question. So if we took this, our old account, which does have the signer, and we added that as the source and generated this transaction, we're paying a different account, but the destination doesn't matter. There's nothing being signed for that destination. So again, the signer's the same. We just have a new signature. With any luck, this actually will submit successfully to the network, which again is why this particular contract is so dangerous. Anybody could put in their source account, or anybody could put in their destination account and just farm 1 lumen at a time from this TX function.
So with the contract executed, then I'm thinking about the logging of seeing the current state of a contract. In this case, there isn't one. It's either you'd be looking at
probably
you're going to be querying Horizon. Yeah.
So in this case, like if we wanted to put in, let's look at Stellar Expert. This is better for looking at logs. If you actually wanted to look or needed some sort of state of the blockchain, you'd be looking at Horizon. You can see all of these one payments. These are the ones that went out to make payments for uploading the contract, uploading the turret, or uploading the TX sponsor, and then you can see the payment to myself and then the one that we just executed. So that's where the logs are coming from. And you could do, like, we could include some logic in here inside of the contract itself that essentially would say something like any sort of arbitrary logic. But if we would do like a get account or get source account payments, and if the destination has already been paid, fail. So in that case, you could look up the state of the blockchain and say, if I've already made a payment to this account, like don't let the same account keep farming and keep claiming 1 lumen. So I'm going to look at the state of the blockchain and say, if they've already made a claim of 1 lumen. So it's almost like your ICO in a sense, where if this account has already claimed tokens from us, they can't do it again, sort of a thing. And so the state of the source of truth is the Horizon blockchain in this case. It could be anything though. You could pass along like IP address information, which they could spoof their IP address. That's probably a bad example, but some information either coming in or address information, account information that you can look up. Maybe you're tapping into some fraud information on some third-party service connected by Chainlink or something that says this account is known for spamming, or maybe it looks up some KYC information from some third-party service provider, either within the Stellar network on some of our anchor services, or some other third-party service. You could look up information like that. It really depends again on how decentralized it needs to be, how real-time it needs to be, but because it's arbitrary Turing complete programming logic, it can really be it can kind of be whatever you want it to be.
Well, I'm just thinking as we go into the last 15 minutes of our session, if we go to the one of the areas that I'm really interested in, the multi-step contract, and without trying to develop the code now, to get into the basic building blocks of what it would require to make this. So let's say we're going to set up a contract where we're going to get people to pull together a certain number of lumens, and we want that added into an account by some time in the future, let's say 7 days, and this contract is completed when we reach, let's say, 1,000 lumens, for example.
Mm-hmm.
But if we don't hit it by time Y, then we're going to return the funds back to everyone that put lumens into the pot. How will we build that out?
Sure, great question. There's a couple of different ways in my mind. Again, the first way to think of it is not in Turing signing server terms. It's just how would you accomplish that in a sense, worst case scenario, the most centralized case scenario, like not considering any security concerns, just really thinking through functionally, if the world was perfect and nobody wanted to hack or cheat, how would I accomplish this?
Yeah.
The way that I would probably do it, there's two ways you can do it. First would be, or two ways that I can think. There may be more, but right off the top of my head, there's two. The first would be payments are put into an individual account. So anybody can make payments in. That's going to be tracked on Horizon, right? It's going to track who paid it, how much they paid, what time did they pay. All that information is tracked directly in the data, in the core of Horizon, or in the core of Stellar, and then exposed through Horizon. As long as you have a timestamp that you're running off of, whether that's weekly, maybe you could put it into the managed data attribute, right? That says this was the last time distribution was run, and therefore this is the timestamp we're going to use for the next X duration. However you do your time doesn't matter too much, but you just need it to be on the blockchain. So whether that's the last time this payment was made, or like a distribution was made, you can look, query the transactions for this account and say, oh, here was the last time a transaction was made from this account, which never happens unless it's a distribution. But I would probably use, just to be explicit, I would use a managed data attribute where you put a very explicit key inside the account itself that says this is the last time we did X. This is the timestamp we're building off of. And so then anytime a turret contract is run, it's going to look at that timestamp, and first it's going to answer the question, is it time to run again? Has it been a week? No, it has not. Kill this request, throw an error. If it has, so that particular piece is really easy to solve for.
Yeah.
The next one would be, what if it is time to run? So let's say we were trying to reach a goal of 100,000 lumens, and so now there's two scenarios. The first is we did hit 100,000 lumens, and so some payment needs to be generated to not the users, right? It's sent out to whoever was trying to raise the funds, right? There may be more complex logic around who it gets sent to, how often it gets sent out, how much gets sent out, at what interval, but essentially according to your parameters, it's like green light. We need the big best case scenario payment to be made, right? So that one's easy because you're essentially just checking the account balance and saying, is it over 100,000? If it is, we're green.
Yeah, absolutely.
So I mean, if you look at the screen here, that's exactly what this is. You would just go to your account balances, look up XLM. Is it greater than or equal to 100,000? If so, do X. Otherwise, we go to our case of no, we did not reach the amount that we needed. Therefore, we need to make payments back to all of the users who paid in so that they can reclaim their XLM, right? At this point, things get hard.
Yes.
Not because it's tricky to make payments to people, not because it's tricky to figure out how much and who, but because if it was hundreds of thousands of people, you can't make 100,000 payments in a single request. So it's going to have to be tiered or layered. You're going to have to figure out a way to battle concurrency. So like if it's 10 people, easy. You basically just comb through, you say, okay, there's 10 people paid in, they paid this much, we're going to make an XDR that reverts those payments and pays them back the lumens that they paid in. Easy, no problem. But the issue is, what if it was 50? What if it was 100? What if it was 1,000? What if it was 1,000,000? Now you've got an issue because regardless of where you run it or how you run it, that's a lot of payments that need to be run. It's going to have to run at least over multiple requests, and most likely over multiple ledger states. So you can only shove so many operations into an individual ledger. So you're probably going to need to make multiple requests. So now there's two options in my mind. One is have users reclaim their own balances individually. So there would probably be another TX function that would say, there's one TX function that you run that says green light, do something, make this payment. If it's simple enough, if there's not a ton of operations. If it's a red light, error. And that would signal to a user, oh, I need to go and make an individual request for myself to reclaim these lumens. And maybe they're the source account. So they're the sequence number that's being consumed. And so they make a separate request individually that says, hey, I made a payment for this account that I put into the parameters. I would like to reclaim my own lumens for putting these into the pool. And so they would make a request that the turret would check. Did you actually make a payment to this account? How much was it for? Okay, everything checks out. We haven't paid you already, right? So you'd have to check both those things. Do we actually owe you anything? Well, essentially just that one question. We owe you anything? And then how much do we owe you? And then it would generate an XDR if everything was green lighted on that turret or that TX function, and then generate an individual XDR with just that one operation to repay them. That's probably maybe how I would do it. It really depends on how automated does this need to be? Is it unacceptable for users to have to reclaim their own lumens? Because what the other alternative is to just continuously send requests to the other turret and actually have logic. So don't throw. Just say, well, we've got 1 million of these to churn through, but we can only get through 100 in this request. So let's get through 100, and then we'll mark a cursor on where we finished. So here's 100 repayment operations. Sweet, let's submit that, and then run it again, and then run it again, and then run it again based off that cursor, and just keep churning through until eventually you get through the million. Like regardless of how many you have to pay through, or regardless of whether or not you use turrets, 1 million payments is just going to take a long time to get through.
Yeah.
So
Interesting.
on the turret
it's complicated.
side, it's more, it's a stellar problem. It's not a turret problem. The turret thing, all it really adds is multiplicity to a centralized service. So whatever you're doing centralized, now you can do it decentralized. You can replicate the process across multiple decentralized third parties. So now there isn't one person trusting, man, I sure hope this account pays us back because I would love to put in, $100,000, but I'm not sure I trust them not to run away with this or not pay me if they don't reach it, sort of a thing, right? So the decentralized piece is really important because it adds trust where I don't need to, or it removes trust, so I don't need to trust that donation pool account. It's not controlled by anybody. It's controlled by turrets. And so now there's that layer of trust that I'm willing to put more money into it. But now you've got the programming challenge of how do we actually make these repayments if the volume of payees is quite high. Another way you could do it is instead of individuals making payments into the pool account, they actually do claimable balances. So similar to how the fees work. And so they just put a bunch of claimable balances in, and then the turret or the pool account, whoever's running the claim piece, says you have until X date to actually claim these things, or you can't claim them until this date, but then you have 7 days to actually claim them all. And if you don't claim them, then the user gets to claim them back. But you can only claim them if the total of all of your pending claimable balances is the sum of all your claimable balances is over whatever the threshold was. And that would be set up in that TX function. So you can claim it, but only if the sum is over a certain amount. Otherwise, you can't claim this. And then once the secondary predicate passes, the user is allowed to reclaim their claimable balance. So that's a whole other sort of way of doing it.
It also, I mean, for me, it shows the importance of having at least connecting to preferably a decentralized database that's nice and quick, which is difficult because decentralized and quick doesn't always go together hand in hand. So, as soon as you can store a table of payments and you can work through that and update that data, it all becomes very, very easy. You have fully decentralized with storage, and it turns much more into a normal programming issue that you're solving, whereas you're really having to think outside the box and leverage the Horizon ledger.
Yeah, at some
And
level, your
yeah,
problems don't go away just because you can answer a question quickly, because you still have to execute payments, and if that's at any sort of scale, you've still got issues
yeah,
for doing that concurrently. I would agree that answering questions quickly is really important, which is where having a decentralized store, could be really helpful. But honestly, I think some of that is just custom horizons. So we're not relying on current Horizon queries to answer our questions. So we're not pulling through 200 at a time until we get through all the payments that are interesting to us. But where we can more specifically write like custom SQL queries as part of our contracts to say, I'm only interested about answering this specific query for my contract in regards to payments from this account or claimable balances over this amount, because the SQL, the Postgres database table, is actually pretty well organized. It just needs to be indexed on specific things to where you can answer those questions more easily. At least you can answer them a lot faster. But it's like every contract is going to have different requirements. So it becomes really hard to sort of say, well, what should my custom horizon support? Because it can't be unbounded. Otherwise, people are going to say, give me all the operations that have ever happened and crash your horizon. It has to be limited in some way, or at least you have to sort of know how much something is going to how much a query is going to cost before it runs. So that, okay, if you want all the operations from the Horizon database, that's going to cost you $1,000. But if you're willing to pay that, I don't care. Go for it. So those are questions that I think Turing signing servers should answer eventually, but they're not simple. So they're not ones that we've addressed yet. And Horizon does do a lot of stuff already without the need for any customization. It really becomes how many users are making payments, like how many queries do you need to make, and are there ways to get around that by managed data attributes where you store where you don't anticipate doing everything in a single request, but you can somehow sort of almost build jobs and then store the state of like, where do I pick up in the next job in the account managed data attributes, almost like the cursor. You store a cursor of, this is where I finished the last time I ran, and when I run again, I'm going to pick up at this cursor. You definitely have to think outside the box, but that's true of DeFi. As soon as you pick to do DeFi, you have to think outside the box.
I got two last questions for you, just to round off our discussion. Well, number one is, I noticed you again going to NFTs, because you made some comments about in the NFT thread saying, "Hey, we've got turrets." The first question is going to be, given what turrets can do, what are the obvious use case? Not use case. What are the obvious opportunities that the Stellar community could be thinking about when they're looking at NFT development? That's number one. And then number two, I thought it'd be good to close out with, production. Where are we with production? What should people in the community be doing in terms of timescale planning to get turrets out in anger in out there in the world?
Sure.
So, let's start with number one, NFTs. What are your thoughts?
Yeah, so number one for me is interesting ways to sell art. So really looking at the, and this is more personal, not like this is definitely the way you should go. But when I think about what's interesting about DeFi in the NFT space, or really just in the artwork sale space or asset sale space, is more interesting ways to do sales. So like residual benefits, when you sell an NFT. So rather than the owner getting paid 100% of the profits, the original artist always gets some percentage of the sale.
Yeah. Yeah.
You can only do that with some sort of secondary logic, so that this thing can only be sold by a turret, and it can only be sold when the original author gets some percentage, 5% of every sale. That would be pretty easy, actually very easy to do with turrets. And the way that you have like asset flags where the thing can only be sold through through like an atomic swap, a sandwich transaction where authorization is opened, sale is made, authorization is closed. So any individual owner could only make a sale of an NFT through that turret, and that turret contract dictates that a part of the payment has to go to the original author. That one would be super cool. Another one that would be interesting would be residual payment benefits for owning an asset earlier. So everybody who ever owned the asset gets a payment every single time the asset is sold. However, the earlier you owned it, the higher your percentage is. So the original owner maybe doesn't even get anything, but the reason they buy it is so that as it's sold in the future, slowly their percentage moves up. That one's dumb, but it's super interesting to me that there's so many like selling opportunities, market opportunities, business opportunities that were never available because traditional financial markets don't support the kind of arbitrary Turing complete solutions that you might want out of selling something. And so we're in this unique space where we're mind blocked into thinking about how payments actually work or how transactions actually work. And it's really hard to get outside of that box to thinking about how could we transact? What is possible? When anything is possible, like what do you do? And so we need minds that are thinking more around, less around like profit and more around, or I guess less around individual profit and more around how could you, like, is there a reason not to do these things? So if you're thinking about any sort of payment opportunity or any sort of distribution of wealth when a sale is made, sort of who gets the income from a sale, as you start to think through, like, so many things become possible and so many mechanics become possible. I mean, really, like, it becomes limitless. And you start adding that into gaming mechanics or community mechanics or open source communities contributing. You can now pull in an infinite number of variables to make an infinite number of distributions of that wealth, and they become possible. And that is overwhelming if payments are manual, but they're not manual anymore. I don't have to go to PayPal and type in numbers to get you a payment. These things can happen completely automatically through 100% programming, and all you do is just spend time on an interface playing a game or contributing to an open source repo. And in the background, webhooks are sending information to turrets that are getting you paid. That's extremely interesting to me. As music gets played on Spotify, money just shows up in your account. Nobody has to type anything in. There's no manual checking. There's no third-party services. It's all just happening through webhooks on a decentralized network in the background. And now sort of anything becomes possible. And we need to be thinking in those terms, but we're like mind blocked right now. And it's really hard to get people to think outside the box because we've never been able to do that before.
Yeah, it's I'm having a lot of chats with Matt, business partner at Task, and the NFT word is so it's kind of media laden at the moment, and that's a problem because the what an NFT represents in terms of certification or existence or uniqueness, it's if you take that, I'm very interested in it in terms of physical assets. And one of the questions that comes up is, well, could you tie an NFT to a physical asset? Let's take a tree. It's always the obvious example, because the worth of a young tree is very low. Most of them die a few days after being planted. So what if someone who had an NFT was a custodian to look after a natural asset, and they had a duty to prove that this asset existed, and as it existed over a period of time, the payment that was being released as a consequence of this asset still existing increases over time, and the custodian would then burn the NFT if they couldn't prove that it still existed. I mean, it's a bit rough
No,
as
but it's
old
a great
boots,
idea,
what
and
I'm
I think
trying to
it
say,
works.
but it's
I think it
yeah,
absolutely
it's
works.
that harnessing of value in natural assets. If we can work that out, that is um, that has huge ramifications for how we can care about stuff and people see the value in things and can look at natural assets in a sustainable investment from a sustainable investment perspective. It's a difficult nut to crack, but it's a worthy one to go at.
Yeah,
Yeah.
it's super difficult, but I think again, so much of our challenge is because we're boxed into a certain way of thinking about how things can work when that initial assumption isn't true anymore.
Mm-hmm.
I think things are always going to work off of trust. It's just what's your risk tolerance and what's your incentivization mechanic for doing what's right versus doing what's wrong. And so you're trying. It's not that centralized third parties are wrong. It's that they're able to do what's wrong without any consequences. And so if you're able to
Yeah.
mitigate the consequences or make it such that doing what's right is worth more than doing what's wrong, all of a sudden you've switched it on its head, and now it's not governments and these weird backdoor relationships and under the table deals. It's all contracts run by machines, by third parties that have an interest in making sure the right thing happens, that the people that are invested in seeing the right thing happen, that they're the ones that are holding the keys, and that the person or the entity that's actually beholden to those entities has a reward mechanic for actually accomplishing those things. Because as long as it's more worth it to do the wrong thing, that's what's going to happen. And anywhere
absolutely.
that somebody can find a way to do that by making it look like they're doing the right thing, but they're actually not accomplishing what you want them to do, they're still going to do it. Like wherever the money is, wherever the worth it is, that's what's going to happen. What DeFi gives us, I think, is a way to ensure more and more transparently that the right thing happens, or at least the expected thing happens. And as long as that's true and exposed, and you give the power to the group that actually they have the desire, the group desire to accomplish a specific task, but they also have the power to see that thing accomplished, whether that's through funding or governance. So long as the people who have the most interest in seeing a certain outcome also hold the keys, I think you have the ability to create something that we've never really had before, or that we try and create through governmental structures or penal structures where there's punishments for not accomplishing those things. But then if you pay me enough money, I'll pretend like you did the right thing even though you did the wrong thing. As long as these things are based off of emotion and human reason or human desire instead of machine 1 + 1 = 2, it's going to be tricky. But I think what DeFi gives us is, again, the ability to create those things which we're trying so hard to get away from computers and putting math into those so that it has to be this outcome. It can't be anything but this outcome. And anytime it's not, the machine is built such that the penalties make it so that you lose a lot of money when that happens. And the human desire now is it's more worth it for me to achieve the result that the majority wants.
Yeah, agree. So production, Tyler, when we were in, going through some of the transactions earlier, there was you've made some recent changes. How long do you think before we're at a point of a kind of tentative production?
It's pending an audit at the moment. So I'm trying to get an audit, like a full audit of the Turing signing. We've had an audit of one of the contracts, the DeFi contract systems. And so the next step is actually auditing the protocol itself. And pending that, I think we'll be at a place, pending that and then any improvements that need to be made from the security audit, we'll be ready to move to production. I think we need a lot more like marketing, APIs, documentation, some like tutorials, a little bit of marketing. There's obviously a lot of the quality of life things like better errors and But some of that's just like community involvement helping to improve the reference implementation, because there's a reference implementation and then there's the actual protocol. The protocol is the thing that I'm most interested in, and then the reference implementation needs to be good, but it doesn't really affect the protocol. If the protocol works, if that's effective, then however we implement that is kind of icing on the cake. So we're trying to get the protocol to a place where we're confident that it's production ready, that it's secure enough to actually achieve the things that we want. And then we get the reference implementation to a point that we can switch the flag and move this to production. I mean, we can move it. You can set up a production turret right now.
Yeah.
The issue is, I don't know if I would make that unbound to the whole internet. And if people don't have the right documentation to ensure that they're building contracts that are actually secure, people are probably going to lose money, not because the Turing signing protocol is bad, but because you didn't write a good contract. There's just this like mental switch between I wrote a function in a private server that no one has access to, that it's all protected by authorization tokens and nobody can just send me arbitrary JavaScript to run, and then switching that over to they can send you anything and run whatever and make sure you're ready for that. So there's just some education that needs to happen, but I mean, you could switch and make a turret that runs in production right now. You, if you wanted, could make a fork of the reference implementation that does implement authorization tokens, so that outside of just fees, you could also include they have to have an account on your Turing signing network. You could write a private network. So in the interim between fully production ready and where we're at right now, you could just run your own like 4 turrets or 3 turrets, however many. And sure, it'll be a little bit more cumbersome, but at least you'll be running on turrets so that when there are other turrets to run on, you just transition naturally over to what they have.
Yeah.
And then you're decentralized. Because again, there's nothing about turrets that's unique. It's just we're building a protocol that a lot of people will agree on, all be running the same thing. And by that, you get decentralization. You're going to run the same function, the same JavaScript function on your server or the Turing signing network. That doesn't change. What changes is you don't own the Turing network. So if you're running your business logic there, you're running it in a decentralized way. Whereas if you're running it on your own servers, you're running the same code, you're producing the same XDRs. It's just all your users know if you decide to quit or to change the background logic, that's bad news for them.
Yeah, agree. I think your point, which is number one, can you do it without, start without the, do everything without the smart contracts. Make sure you need the decentralized system, and then apply to that. I mean, we have requirements around minting of tokens against particular inputs, particular data that's been gathered. Trees being a good example, number of trees planted, but what's the tree type? And depending on the tree type, there's a different value to those trees. So you're going to apply a multiplier, and you may have some token which represents impact, and you're going to mint a number of tokens that's based on on that input. Now, on the multipliers on those the data that's being gathered. Now you can get going with a centralized system, and that's fine. But longer term, if you standardize these inputs of number of trees, and that this is something that you can put decentralized, and it's a open system that's understood, saying provide these inputs, and we're minting these impact tokens, and then the currency of that token represents the impact, and it's all understood because it's within the contracts that you defined. So centralized can be okay for proof, but it's not really great for longer term thinking.
Yeah. Yep. I agree. Again, it depends on your use case and your business model, but if you can be decentralized and it works, there's a lot of benefits there, particularly if it's around security, and trust is something that's a barrier for your users.
So production, 1 month,
Oof.
6 months?
Yeah, I would like it to be later this year. My hand is more on Stellar Quest and the Stellar Community Fund at the moment. We have some third-party enterprise clients that are interested in the Turing signing network, and they're leading the charge a little bit more on that. Again, I think the audit will probably be the next few months, but I cannot guarantee much of anything other than the code's out there, and
Yeah.
anybody's welcome to it. There's nothing in it that can't be changed. It's a community-based project, not really an SDF project. So some of it's up to the community. I think we will have a audit done of it, but then the changes that'll be necessary some of those will be run or accomplished by community members and clients that have vested interest in seeing it succeed. So at some level, the answer to that question relies on folks like you and Script3, other companies and enterprises that have a vested interest in seeing the thing succeed.
Great. We have. I'll just end on the fact that we've just taken on an intern who will be working full time for the next month on turrets, and then will be part time for a number of months. And
amazing.
He seems to have really good JavaScript skills and wants to get inside all this. So
Super.
You'll hear more from that soon.
Yeah, make sure. I think you're in the Turing Signing Server Discord, right? So make sure he's in there to ask questions, and as he has suggestions for improvements, make sure to have him forward.
Great. Well, thank you, Tyler.
Yep.
Really appreciate the session.
Yeah, absolutely. Thanks so much for jumping on. All the great questions. Hope this has been helpful. I'm going to call out really quick the tss.stellar.org to keep up with progress, and then that reference implementation that's linked to there. There's also the Turing Signing Server Discord. Make sure to join that for anybody that's interested. Super interesting, exciting protocol that's growing and changing. Even as we already saw today, there's updates that happen. It's still in its infancy, but a very exciting point to get involved. So thanks all for watching, and we'll catch you, I think, in a couple of weeks. We're doing one on kelp with Nikhil, so be sure and jump back in for that. Otherwise, I will catch you all later. Thanks so much for joining.